Before diving back into Adam, Eve, or more hominins, we need to take a step back, okay? We're going to ask a deeper question. What makes us human? We'll explore how archaeologists and anthropologists classify the genus Homo and what separates us from the other ancient hominins like Australopithecus. Welcome to Dry Bones, Faith and Archaeology in Conversation. My name is Kathleen. I have a master's in anthropology with an emphasis in archaeology. I'm also a Christian. I always like to put that bias right up front, even though this particular video is really not going to delve a lot into the faith part of faith and archaeology and conversation. I still want to make sure you know where you are. So my last video, I talked about the Neanderthals, and that's going to be a part of a playlist, and a much wider playlist where we're going to talk about each one of these hominin species, these Homo species. I should be more specific, the Homo species, and how I want to teach you guys about what each one of these species was about, what we found out about them, what we don't know about them, how they're connected. But then I want to explore this idea of the biblical Adam and Eve and how that fits in. But I thought it was really important to kind of take a step back. What I want to do is focus in on the genus Homo, because I want to create this foundation for you guys of what that is. I want you guys to understand what it means when scientists use the term Homo. And then hopefully that will help you understand when there are discoveries about like the Neanderthals and the Denisovans and Homo naledi and why there's debate over if they fit into the Homo genus or if they don't fit into the Homo genus. And then as that goes into that overall story of all the species of Homo, looking into, and Homo is human. Homo means human. How that fits into this biblical account of Adam and Eve and where they fall into that, if they fall into that, if they don't, and just kind of explore that. So today's episode is going to be pretty much all archaeology instead of where I usually try to bring in how things do connect to the Bible, do or don't connect to the Bible. So today what we're going to discuss what defines the genus Homo. We're going to discuss that process of classification that happens. We're going to discuss how the genus Homo differs from Australopithecus. And then we're going to briefly touch on that full list of species that comes underneath Homo. But the reason why I paused there is because there were some I took out if there was just too much debate over them. And then we're also always finding new ones. And even like they know in our DNA that there's these ghost ancestors. So it is a relatively full list of species underneath the genus Homo. And we're going to start with the most recent when we do that. So let's define a few terms. If you've watched me a little bit, you know I like to define terms. As I mentioned before, genus Homo, that word is Latin and it means human or mankind. And that is what we call a taxonomic classification for modern humans and many extinct humans. So I know not everyone deals directly with this. So some of these you guys are going to know, some of you guys aren't going to know these. So I'm just going to define a few similar but different terms that we will use in this video, but then also I'll be using in other videos. So I want you to have a good grounding for that as well. So we're going to define taxonomy, phylogeny, and clade. All right, so taxonomy is the branch of science that is concerned mainly with identifying, naming, and classifying organisms. So it is sort of like this filing system for life, if that helps you kind of understand that. Carl Linnaeus is the one who came up with this. He was a Swedish biologist and physician in the 1700s. He was the first to officially formalize this binomial nomenclature, which is this modern system of naming organisms. He also developed this hierarchical system to organize plants and animals. And so it looks a little bit like this. So you start out at the top, domain, you go down to kingdom, phylum, class, order, family, genus, and species. We are only going to be focusing today on genus and species. And so understand that under each one of those, so when you have domain, that's going to be a lot of organisms. And then you're going to have a little bit less with kingdom, a little bit less with phylum, a little bit less with class. So it's going to keep refining itself more and more. So when we talk about genus, that's a lot more organisms than when we refine it down into species. So again, today we're focusing on genus. At the end, we will talk a lot more about species. And then in future videos, I will talk a lot more about the different species. Okay, so let's define phylogeny. Now, phylogeny refers to the evolutionary history of the development of a species or of a taxonomic group of organisms. So this focuses on evolutionary relatedness and history of these organisms. It's not concerned with identification of these organisms like taxonomy is. And then define clade. A clade is a group of organisms that consist of a single common ancestor and all its descendants, both living and extinct. So both phylogeny and clade provide this framework of understanding how life has evolved from common ancestors. It will place extinct and modern organisms into this evolutionary context. And these different relationships are depicted in the form of either a phylogenetic tree or what we call a cladogram. The phylogenetic tree is similar to a family tree, but it's just dealing with a much bigger picture than just brothers and sisters and aunts and uncles and stuff like that. So you can have a phylogenetic tree that looks a bit like this one. And you can see how these lines, you'll see the time frame across the top, and then you see the lines that are underneath each one of these. And that is giving you this idea of the length of the line is kind of showing you how long that, in this case, how long that species was around. And then the connections with each other, you can see how they line up with which ones overlap. And then you also have one that looks a bit like this one. And this one's a little bit more colorful. It's got that tree look to it. And this one actually makes it a little bit easier to understand a clade. And so when you think about a clade, what you can think of is if you were to break off any one of these figurative branches, everything above the break would be a clade. So hopefully by looking at this particular illustration, you can see how each one of those would be a clade. So while a phylogenetic tree adds information about evolutionary time and genetic distance through its branch lengths, a cladogram shows the branching order based on the shared characteristics and a common ancestor. And it's going to look like this. And so as you can see on here, as you add these physical characteristics, the organisms will either fall off or continue on down the line so that you're getting more and more that are similar and more similar. And usually the lines on a cladogram are typically, they're just kind of arbitrary. They're not related to any kind of time passage. So as we talk about the genus Homo and how it is classified, I hope these definitions have helped you to kind of have some grounding. As we talk about the characteristics, understand that the term Homo is both genus and clade. So let's talk about how the genus Homo is classified. So this video is not going to deal with the debates that happen with the genus Homo, because there are a lot, but I do want you to understand that there are debates. We are going to go into that a little bit, but I just don't want to spell them all out in this one. I just want you very aware that there are debates over this. So when we define this term Homo, what we're kind of really doing is defining what it means to be human. It is a scientific classification, yes, but it does kind of also open these deeper questions about consciousness, morality, identity. We talk about, making art. We talk about burying dead. We talk about cognitive. And so I think that kind of comes into play when we talk about being made in God's image too. So it is this really deep kind of conversation that can be had with what classifies as this genus Homo. And so we can stay on track with some foundational understandings because of those debates I mentioned a bit ago. I am taking the most accepted positions and mostly what has been proposed by Mary and Louis Leakey. Mary and Louis Leakey are these very famous paleoanthropologists that made many groundbreaking discoveries in the field. And so I'm going to be using basically how they define the genus Homo. In general, most of the genus Homo will show this evolving mix of archaic or primitive. Sometimes we use the term archaic, sometimes the term primitive, and modern traits. But it's going to be more and more weighted towards these modern traits. The traits we're going to look at include the large brain size, certain types of skull features, the small jaw and teeth, habitual or obligate bipedalism, a precision grip, and complex tool use. So we're going to break those down, right? So brain size. So let's talk about brain size. The brain size is going to be relatively larger than previous hominins. And that typically means that it's going to be over 600 cc's. There's going to be some caveats to that, and we'll talk about those as we get further down. But typically, it means it's going to be over 600 cc's. And for comparison, that's roughly 1/3 of the brain size of modern humans, and it's closer to what we actually see in today's chimpanzees. The largest brain size that we've seen come out of the fossil record is about 1,700 to 1,800 cc's, and that's what we're seeing in Neanderthals and Denisovans. Homo sapiens, interestingly, are around 1,500. The skulls are going to become more and more globular, more of that round to it, instead of more of the stretched out. We're going to see them be a little bit less prognathic, and what that means, that prognathic means, prognathic means that your face kind of juts out a bit. And we see this more because usually they have like that larger jaw, that sort of a thing. So this face kind of juts out. So we're going to start to see that face become a little bit more flat, the features a little bit more tucked under that brain case. We're going to see smaller jaws and teeth. So let's talk about habitual or obligate bipedalism. And this is when you're walking on two legs as the main mode of transportation. So not just that you're walking on two legs, because we do see that in some animals today where they can walk on these two legs. But we want to say that this is this habitual or obligate bipedalism. And so it doesn't, and understand too, it's a mix of these features. So you may be saying, wait, there's animals that walk on two legs and we don't even consider them even kind of close to being human. Right. That's because they don't have the other features. They don't have any of those other features. So it is this mix. So these are different features combined together. And as they lean more and more towards the modern Homo sapiens, we term them more and more into this genus Homo. So how do we tell a skeleton is bipedal? So typically, it is marked by the foramen magnum, like what you see here. And so this is a hole in the bottom of your skull. And this is where that spinal column is going to come through. Or if you can look at this picture and you can see that when that head is upright, that spinal column is going to come straight down. And then if it is an animal that goes down on their arms, and more likely kind of like this with their head, or like their head is like this, that foramen magnum's going to be more out the back of their skull. And that is a really good tell, because if it was an upright and the skull was, and the spinal cord was coming out the back, like that's going to be a very difficult position to have. And if it's on their all fours and it's coming out the bottom, that also is going to make it a very difficult position to hold all the time. We're also going to start seeing relatively longer legs to shorter arms, as the arms are no longer being used as much for locomotion as tree dwellers would have been doing, like grabbing onto those branches and swinging across. So we're going to see that more. We're going to see an S-shaped curve to the spine, and because this is what brings that center of gravity over the feet. We're going to see a more robust lower back or the lumbar vertebra from holding that body's weight. We're going to see a shorter and broader pelvis because that's going to help create that stable base for the torso. It also is going to put those legs more towards the body's center of gravity. Then we're going to see the valgus angle of the knee. And this is where the femur and the tibia meet. And when we look at that valgus angle, we're going to see that femur or the thigh bone, it angles inward, which will improve that balance and stability when somebody's walking on two legs. We're also going to see the arches in the feet. And this is going to develop for shock absorption and propulsion. We're going to see more of an alignment of that big toe because that big toe is no longer going to diverge like it's seen in tree climbers, like where they sort of grasp onto those branches with their feet as well. But it is more aligned with the other toes, so it can be used as that final push-off point when walking. We're going to see a large heel bone, which will handle more weight and impact from the walking. Then we're going to see this precision grip. And a lot of you guys, I'm sure, know about this as opposable thumb idea, right? Where we can, there's this idea of having that hand dexterity. And we're going to see that more and more of that precision grip is going to get better and better. And then in direct relation to that, we're going to start seeing this complex tool use. And so when we talk about this complex tool use, Jane Goodall is very famous for having recognized that the chimpanzees were also using tools. But the difference that we're seeing is that when we see the chimpanzees using tools or the bonobos using tools, they are finding an object, then using it as a tool. What we start to see in the genus Homo is that they are deliberately creating tools to be used for very specific functions like butchering and scraping or piercing. And the type of tool making we see in the genus Homo, it starts very simple with Homo habilis, making very simple tools from just striking stones together. And they're creating like these flakes with a sharp edge. And with that sharp edge, they can use to cut, they can use to scrape a hide with. And so as we get closer in time and to modern time, the complex tool making we see is going to help define that genus Homo because it's reflecting on this increasing cognition and behavioral complexity. And it's really, really cool. This was one of those things that I just really enjoyed learning about, understanding flint knapping. I think what I'm going to do as well, we're going to talk about a couple of different of these tool making methods. And you'll hear me talk about Oldowan, Levallois, Acheulean. And what I'm going to try to do is put videos of those tools being made in the description if I can find them. I'll put them in the description because I think it would really help you guys visualize what these tools were, what it took to make them, and how you can see the cognition in the brain would have had to work more than just simple striking and just by chance getting something. All right, so who decides the classification? So when a new fossil is discovered, what happens is that the researchers will publish their findings and they will propose a genus and a species designation. And then through peer review and this community debate, that's going to help shape that scientific consensus. So while there's no central authority, this process is governed by a system of internationally accepted codes and conventions, along with that scientific community consensus. And this, though, is part of why it is hard to determine exactly how many new Homo species there are, because when new remains are found, these lumpers and splitters really kind of go to town and start debating if it's going to be determined as a new species or not. And let me explain lumpers and splitters. So lumpers are those that want to have a much wider and broader umbrella to put a designation under. Splitters, though, want to get really specific with them being different species if they have a different set of traits. So more species, so splitters will do more species, lumpers less species. So also keep in mind that when we do have these new findings, the classifications are going to become more and more accurate. And the former designations also then can be reevaluated. And this is why there is debate over defining species. It's why there are certain designations like Homo habilis that are questioned whether they belong to the genus Homo or the genus Australopith. There's another example would be Homo naledi, and this was discovered in South Africa in 2013, and it sparked intense debate because its brain was small. And that was more like Australopithecus. But its behavior suggested this complex social structure, and there's even possibly intentional burial discovered with Homo naledi. And so those are these more modern human activities, but yet it's got some of these features of Australopith. So there are some people who argue that Homo naledi shouldn't even be in the Homo at all. And so you can see there's a lot of debate over these, and that's really good and really healthy, right? So that's scientists checking scientists, scientists having debates, and everybody's got to come up with their good argument as to why it should be one way or another with good science to back that up. And then once it's classified, you're going to have organizations like the International Commission on Zoological Nomenclature, also known as ICZN. And this maintains and revises this International Code of Zoological Nomenclature. This code will provide the universally accepted set of rules for the formal naming of animals. The ICZN will also rule on specific cases of nomenclatural uncertainty, just to kind of try to ensure some stability there. So what separates the genus Homo from the genus Australopith? So the Australopithecus species lived about 4 to 1 million years ago. And so what we see is this overlap. As they start to disappear, we start to see the genus Homo and these new types of fossils starting to emerge. And the Australopithecus, it did show bipedalism, but it had these more ape-like features. It had the small brains. It had robust jaws. It had the long arms. While on the other hand, Homo species show larger brains, the smaller teeth, these modern limb proportions, and a more standardized tool use. And so this transition was gradual. It was not abrupt. Australopithecus sediba actually exhibits both genera's traits, and it shows this what we call a mosaic evolution. And so the term mosaic is used when it's regarding features. It's this blend or mix of characteristics that just fit with more than just one species. So let's talk about species that come underneath the Homo genus. And we're going to start with the oldest one. We're going to go to the youngest and understand what I'm saying, that what we're going to be doing is the oldest one that we see emerge, not necessarily the oldest one we see disappear. At one point, it was thought that one evolved into the other. And so we didn't think that they could survive at the same time. So we've since come to realize that many of them overlapped and lived at the same time. So these are going to be brief overviews to help you understand the genus Homo and how these traits we talked about present themselves in each of them. But in the future videos, I'm going to take each one of these and I'm going to really delve in to more details with these. All of these are habitual or obligate bipeds. but they do become more and more so as we get closer to modern humans. And that's what you're going to find in these is this combination of archaic and modern characteristics, a little bit like that mosaic we talked about, but we're going to see this start to evolve through time. So I want to see if you can pick out the archaic ones versus the modern ones as we go through them. I'm going to tell you what they are, but just sort of try to beat me at figuring out which one's archaic and which one is a modern feature trait. So first, we're going to start out with Homo rudolfensis, and this was around about 2.5 to 1.8 million years ago. It lived in East Africa. Again, it was first discovered in 1972 in Lake Turkana, East Rudolph, Kenya. That's where it gets its name from. Its brain size was about 775 cc's. It had a long, flat face, not prognathic. It had large molars. It had a slightly developed brow ridge. And there actually are no stone tools directly connected to rudolfensis. There's also no postcrania bones. So we do have, we don't have all the information about it that we would like. So we don't know what its grip was like. We don't know what its limb portions were like. But what we do know is that it had that foramen magnum in the bottom of the skull. So that is suggesting that bipedality. Then we have Homo habilis, and Homo habilis emerged about 2.1 million years ago and lasted till about 1.5 million years ago. It lived in eastern and southern Africa. The first fossil was discovered by Lewis and Mary Leakey. I mentioned them before in 1960. It was found in Olduvai Gorge in the Great Rift Valley of Tanzania, East Africa. Olduvai Gorge is very, very famous as a place where we see in the Great Rift Valley many of these fossils come out of. It had a brain size of about 500 to 800 cc, so really small. It had a relatively large brain for its body size. So even if we're seeing it at the 500, earlier I mentioned that it would be 600 or above. But sometimes what they're looking at is that relative brain size to the body size. It was the first to show this significant increase in the brain size. Its brain is more rounded than the previous hominins. It starts to have this bit of a slight forehead. It does have a smaller brow ridge than before, and it has the less prognathic face. And if you guys remember, I explained this earlier, the prognathic means it had a more flat face. It had a less protruding face. It did have Australopith-like jaws and teeth, meaning basically they were still pretty large, but they were still smaller than the previous hominins. It was small. It had short legs and long arms. Do you guys remember about that? If it had short legs and the long arms, we talked about how those long arms were probably used more for still being in the trees a bit more. And when I say short, it was about 110 to 130 centimeters, which puts it at about 3.6 to 4.2 feet tall. So pretty small. It did have a precision grip, more than the earlier hominins, but it still didn't have that fully opposable thumb. It used simple stone tools, so we do see it using stone tools, and this was the Oldowan tool industry. This is where they would take a core stone and it was struck with a hammer stone, and it would create, like I mentioned before, these sharp-edged flakes and choppers. The discovery of the Oldowan tool industry actually really marked a very significant advancement in early human culture and behavior. Habilis, Homo habilis, means skillful or handy. So Homo, which we mentioned before, means human. So the two together means handyman or skillful human. Then we have Homo ergaster and erectus. And they lived 1.9 million years ago to about 110,000 years ago. It is the longest surviving of the Homo species. Now, some of you guys may be asking why I've combined these two. I combine these two because ergaster is kind of known to be the African variant of Homo erectus. And again, this is one of those things that is debated. So whether they are the same or variant is debated, but I just decided to go ahead and put them together so that we can, because they're more likely the same. The first fossil found of the Homo erectus, it was in 1891 in Indonesia. It lived in Africa and Asia. It began to see some early modern traits. Its brain size was 860 cc's. It did have that more domed cranium, more of that globular cranium. It had a flatter face, less prognathic. And here's interesting, it had a more projected nose than the previous species. It had a smaller jaw and teeth than previous species. We said that the smaller jaw and teeth is more of a modern trait, less of an archaic trait. Its height ranged from about 145 to 185 centimeters, or 4'9" to 6'1" inches. So this one was a much taller species than what we saw before in Homo habilis. It had longer legs and the shorter arms. If you guys remember, that's more of a modern trait to have those longer legs and the shorter arms, probably not up in the trees at all anymore. It had a more barrel-shaped rib cage like modern humans rather than the cone shape that the previous species saw. Now, ergaster means work. So Homo ergaster means workman. And erectus means upright. So Homo erectus means upright man. It was the first to leave Africa. It was very widespread. It was also the very first long-distance traveler. It had the first major innovation in tool technology. This is where we're seeing the Acheulean stone industry come about, where they use these large cutting tools like hand axes and cleavers. It had a broader set of tools than what we had seen previous. And what's interesting is this is where we see the first evidence of these hearths and these campfires. And so we're assuming they used them for cooking, but they probably also used them to, deter predators. We might have seen them hanging around and being communal around these campfires. So very interesting to see that pop up there. Then you have the Homo antecessor, and this was around about 1.2 million years ago to 800,000 years ago. This was discovered in Spain, and it got announced as a new species in 1997. It is actually the oldest human remains found in Western and Central Europe. And due to its unique mix of traits, its place on the Homo tree has actually been debated. It has a brain size of about 1,000 cc's, more modern, right? Its skull is more similar to modern humans, except maybe a bit more robust. It has a projecting nose, but even though we start to see this forehead, it still has a low forehead. It has that double brow ridge. It has the occipital bun. And the occipital bun is what we also talked about, we see on Neanderthals. And so we'll talk about that a little bit more when I get down to Neanderthals, but just remember that they had the occipital bun. It did have more robust teeth. That's more of the archaic. It had these shovel-shaped incisors like the Neanderthals, and it did not have a chin. Its body size and shape was similar to modern humans, but it was more robust. But its remains were found with many stone tools, and this was that Oldowan style with those simple cutting flakes. And the name means human explorer, pioneer, early settler. So Homo antecessor means human explorer or human pioneer. Yeah, pretty cool. So then we move on to Homo heidelbergensis, and this was around about 300 to 600,000 years ago. And that first fossil was discovered in 1907. And we find fossils of them across Europe and Africa. And it's thought to be the common ancestor of Neanderthals, Denisovans, and sapiens. Its brain was about 1,250 cc's, so it's much bigger. It did have that sloping forehead similar to the earlier species, so that's more of an archaic trait rather than vertical, what we see in sapiens. It had that wide nasal opening that we also see in Neanderthals. I'm sorry, I'm talking a lot about Neanderthals because I've done that video, and so it's the one that keeps popping up as these traits keep coming up, but we're going to talk about them next. It did have a slightly prognathic face. It did not have a chin. It had smaller teeth than the earlier species, but still larger than modern sapiens. And based on the long leg bones that we see that are similar to antecessor, we're thinking that it was about 180 centimeters in height, so about 5'9". And it used the Acheulean stone tool industry with stone hand axes. It was the first to create also composite tools like a wooden spear with a stone tip. And the name means Heidelberg man. It was named after a city in Germany. We see that a lot, right? Where they're just named after where they were found. Then we're going to talk about Homo neanderthalensis, which I keep bringing up, right? And this Homo neanderthalensis was around about 400 to 40,000 years ago. And it lived in Europe and Asia. It was discovered in Germany in Neander Valley Cave in 1830. Its brain was about 1,700 cc's. It did have a large brow bone. It had a wide nasal opening. There was no chin, and it had these large teeth. It had a prognathic face, so its face did jut out, and it had that sloping forehead, and it had the occipital bun. And this is why I kind of wanted to wait till I got the Neanderthals, because I felt like their skull showed it the best. And so if you look at the back of their skull, you can see that bony area sticking out of the back there. And this is the occipital bun. And what we believe that was used for was the size of the head might have been so big that those muscles that came off that neck were being attached there to help hold that neck more straight. We do know it was more adapted to the cold, and we know it was intelligent. Its tool technology was what we call the Masterian stone tool culture, and it used what we call the Levallois method. And what's neat about the Levallois method is that it needed this visualization of the final product. And to have that visualization of that final product was a very necessary part of creating that tool. And this was very complex, and it required this hand-eye coordination. And why that's important is because it shows the cognitive ability to think in the abstract. And so we also see art come from the Neanderthals, which again is this abstract way of thinking. We see burials of their dead with possible flowers. So again, this abstract, spiritual, possible way of thinking. And so these are signs of that cognition of the Neanderthals. So now we go to Homo naledi, which emerged about 335 to 236,000 years ago. So we're seeing them also overlap. And this time you'll notice that my picture I'm putting up is not of a skull. And I'll explain that in just a second. So Homo naledi was discovered in South Africa. It was discovered in this rising star cave system in 2013. And that again is a really interesting story. It's too much to go into here. It will definitely be a part of that video, but that is a very, very interesting story, how that was found and what it has taken for them to do that research on these skeletons. But what's also really neat is over 1,550 specimens. That's why I used this picture instead of a skull picture, because I wanted you to see how many different specimens they picked up. And just if you haven't seen it, one of my other videos, I did talk about the difference between NISP and MNI. So when we talk about 1,550 specimens, we're not talking about individuals. We're talking about each one of those bones is considered a specimen. So NISP stands for number of individual specimens. But then what they figured out by looking at those, they figured they had at least 15 individuals. And this is where we get the MNI number, which is minimum number of individuals. I'm not going to go into how those two are determined right now. You can watch that other video. I'll put the little card up, I think over here. And you can look back at that video where I explain that. It is the largest collection of a single hominin species found in Africa. It had a small brain size of 465 to 560 cc's. So that's, again, why it's getting debated, right? But that brain size was similar in shape and structure to modern humans. And again, they were only about 5 feet tall, so they were pretty short. And so that brain size compared with being their size gets mixed in there. They had a flat midface. But then they had this large brow ridge, right? So we had the less prognathic meant more modern feature, but large brow ridge is more archaic feature. Their teeth are this mix of Australopith and Homo features. Their shoulders are more like the Australopith. And so we see their shoulders being able to assist with that climbing and hanging. So that's a very interesting feature. Their fingers are relatively long and curved, which indicates this climbing activity. But their wrists, their palms, and their thumbs, so although their thumb was long, their wrists, their palms and their thumbs were more modern. And that assisted them with tool use and object manipulation. So what we're seeing is that their skeleton is this mix of Australopith and Homo features. Now, there are constantly new discoveries made about this hominin. It hasn't been around that long. It wasn't that long ago that it was discovered. They are constantly coming up with new discoveries. So who knows where this one's going to end up going. But part of what we'll talk about in that video is the difficulty about getting down into that cave where the fossils were found. So also the difficulty in researching what was kind of going on in that cave and researching what kind of activities they were involved in. So their name means starman because they're named after the rising star cave that they were found in. Then we come to the modern Homo sapiens. And they have been around from about 0.3 million years ago to the present. Now, these get split up into archaic Homo sapiens and modern Homo sapiens. Sometimes they're called anatomically modern Homo sapiens. Now, the archaic Homo sapiens that they talk about are these transitional hominins between Homo erectus and the modern Homo sapiens. And so there's this mixture of modern and archaic features. And the archaic also typically will refer to those African fossils that are dated between about 300 and 150,000 years ago. And then you have European fossils that are dated from about 40 to 10,000 years ago. And those sometimes you guys have probably heard the term Cro-Magnon man. And those are the ones that are usually referred to as Cro-Magnon man. The archaic are also sometimes classified as Homo heidelbergensis. And again, this is one of those debates that happen. The archaic Homo sapiens have a little bit smaller of a brain size than the modern, but the modern brain size is about 1,500 cc's. And it has that tall and high forehead. It has that globular brain case, like the basketball, not so much like a football. And there's no occipital bun. It has no significant brow bone. That nasal opening is more narrow. And we see a chin. Homo sapiens are actually the only species of Homo that has a chin. And then we also see these smaller teeth. And what's interesting about the smaller teeth, and again, I'll do a full video on this, but I do want to make this little point because I find it interesting, is that when we talk about these smaller teeth, I know a lot of you probably have gotten your wisdom teeth out. Our jaws are continuing to shrink. And this is kind of an interesting thing that we're seeing is our jaws continuing to shrink because we're eating softer and softer foods. So our jaws don't need to be as strong and rough because, like they might have been back then, eating a lot of uncooked tubers or a lot of leaves, and that required a lot of chewing. But as they started to use fire, as they learned how to soften their food, the jaws, we start to see those jaws shrinking. What's also neat is that we see this as the first species to build shelters. So they were just creating these simple dwellings of like wood and stone, but we're still seeing them build these shelters. Now, sapiens means wise. So Homo sapiens means wise human. Now, we're not done yet, even though we've gotten to Homo sapiens, because remember I talked about we're going from when they first emerged. Then we go to Homo floresiensis. Again, a really, really interesting species. It lived around 100 to 50,000 years ago. It is this island dwarf species. It had a really small stature. The female was about 106 centimeters, or only about 3.6 feet tall. It was discovered in 2003. It was nicknamed the Hobbit. And it has only been found on the island of Flores, Indonesia. So a lot of the others had this much wider range, but it has only been found on that one island. And again, when we do that video, that indicates something about the size of it. But I'll save that for that video. Its brain size was about 420 cc, so relative to its body size is probably why it gets classified in the genus Homo. Again, but it's debated. And that's probably a big reason why, is because it did have this small brain size. It just was also a very small individual as well, though. But it had the large brow bone, and it had the large teeth. It had no chin. It had that receding forehead. Kind of interesting. It had relatively large feet for its size. I don't know what that's about, but maybe we'll explore that when we do that video. And despite the small brain, though, there have been stone tools associated with floresiensis, as well as evidence of hunting and fire. So that, again, puts it back into that genus Homo and these more modern traits that we see coming from it. And what is also intriguing is not just their small size, not just that they're found on this island of Flores, but also that for early humans to have gotten over to that island, they would have had to travel over this very treacherous sea when there was not a land bridge. So it's kind of interesting to figure out how they got there. That's a big mystery. So then we have the Denisovan. And I'm not going to talk a lot. I'm actually not going to talk about the Denisovan in this video because I am getting ready right after this. Well, probably in about 2 weeks, I'll put out a video that talks all about the Denisovan. But this, again, is related to Homo sapiens. It's got a very, very interesting story. A lot of what we know about the Denisovan is not through a lot of fossils, but it is a lot known through genetics. And so I hope you guys tune in for that video. I think it's going to be really, really interesting, and we will go over it there. So that is the last of our species. I want you guys to think about that, and because this genus Homo wasn't just this straight path to modern humans. It was this branching, dynamic kind of lineage that happened where these, some had more or less of these archaic and modern traits. So studying its evolution really reveals this gradual emergence of cognition. We see this emergence of technology, and we see it being very adaptable. And that's really, really neat. So when we talk about the genus Homo, we're not just describing the anatomy, we're also tracing this story of their awareness, of their creativity, and of their relationships with each other. It's this kind of long unfolding story of what it means to be human, both in the fossil record and in the story of faith. Even if you're not a believer in God and God creating, you have to have some wonder at these traits of the genus Homo that are so very different than what we see in Australopith and we see in earlier, older, more archaic hominin species. And one of the videos I plan to do is about, are we special? Are humans special? I hear a lot in the scientific community where they say, oh, we're not special. We're just another animal. And I don't know if it's my faith or to me, it just seems very obvious that we are special. And I feel like there's some self-loathing that goes on in the scientific community. These are my own thoughts. I don't understand this. I don't understand how you can't look at what we've done in the relatively short time the Homo sapiens have been on, I don't know if on this earth is the right term, but, been around versus, like the Homo erectus made really wonderful strides in what it did. But I still think that in the time frame that they were around versus the time frame we've been around, I just don't think, I just don't know how you can not say that we were special. And again, that's whether you are a believer in a creator, believer in God creating, or just a scientist looking at this. I just don't understand how you can't see that there is something special about Homo sapiens. So if you were interested in learning a bit more about the Denisovans, where I'll go a lot more into it, so please subscribe. Please share this. Please like it. These are easy ways to help me out. But also, if you subscribe, then you're going to catch that next video when I put it out there. I only put out videos about every 2 to 3 weeks. I hope it's obvious that I put a lot of work into these videos, and it takes me a lot of time to do that research. It's not my full-time job. I have a full-time job as an archaeologist. And so I really want to give you guys something quality to learn from and to discuss. And so if you could like and subscribe and share my videos, that would be really helpful. So if you're also interested in learning more about the Neanderthals, you can check out my video on that here. God bless you guys. Have a wonderful day.
Drive on these eagles, drive them, drive on these